we don't, I mean, in the past, I've done systems of 3 equations and 4 equations. But once you learn how to do 2 equations on your graphing calculator, but we won't today. We'll use your graphing calculator today. But we're going to learn how to solve systems of equations on a graphing calculator. And once you learn how to do 2 of them, then 3 and 4 just follow the same line. And it's really easy. Okay? So we're going to learn how we learned it in Algebra 1 and Algebra 2 today. Then we're going to involve matrices on tomorrow, and then get deeper into matrices next week, and then review for the test, take the test. All right. So a solution of a system of 2 equations is a ordered pair where the systems are the same. Okay? So it's where 2 lines cross if they're graphed. This systems of equations, if I want to use the substitution method, because there's a substitution method and the elimination method and the graphing method. The substitution method, you get a variable alone. What's the easiest variable to get alone there? Y in the top equation. So what I'm going to do is I'm going to add y to both sides and subtract 10 from both sides. So I'm going to say 2x minus 10 equals y. We good with that? Everybody saw what just happened there. Okay. Then the substitution method says that I substitute what y is, and I put it in for y of the other equation. So 6x plus 4 times 2x minus 10 equals 1. Then I solve the equation for x. So 6x plus 8x plus a negative 40 equals 1. 6x plus 8x is 14x. And if we add 40 to each side, equals 41. So x equals 41 over 14. And yes, in this book, they have some nasty fractions for this. And I don't know why they just don't make them equal to whole numbers, but they don't. So you're going to find some nasty fractions here. So what?
Probably more realistic for the...
It's more realistic for the real world, yes. So then, once you figure out x, you plug that back in your original equation that you had, not the original equation, but the equation that you had alone for y. So then you take 2 times 41/14 minus 10 equals y. So you have 41/7 minus 10, and 10 is the same as 70/7, because 70 over 7 is 10. So 41 minus 70 is a negative 29/14 equals y. So it is the ordered pair, 41/14 sevenths, negative 29/7. The solution. Okay? 41/14, negative 29/7. Okay, that's the substitution method. Okay? Now, not all of them will work out to be, not all of them will be, 2 linear equations. So here we have a parabola and another line crossing it. How many times does my line hit the parabola? Twice. So most of the time in these, I'll have 2 answers. Okay. So how do you do this? I'm going to do substitution again. I'm going to take 8x equal to x squared plus 6x. So what do? Well, I can just subtract 8x from both sides. So 0 equals x squared minus 2x. If we factor out an x equals 0, and x equals 2. So where are the ordered pairs where it crosses? 0, 0, because if we plug a 0 into this one, we get 0. 2, 16, because if we plug a 2 in there, we get 16. Those are the two ordered pairs where they cross.
Will they always work, or will be some that?
You could have a parabola like that where there's no solution because they don't touch, or you could have a parabola like this, like this, where it just touches once and there's only be one solution. Okay. The elimination method, which I prefer. What I do is I want to make opposites out of one of my variables. These already have opposite signs, my y's do. So if I multiply my top by 3 and my bottom by 2, my top row becomes 9x plus 6y equals 36. My bottom row becomes 8x minus 6y equals 66. Now I've created opposites out of my y's. One's a positive 6y, one's a negative 6y. Okay, so now that I have opposites, now I can add my columns. 17x equals 102 divided by 17. So x equals 6. Now how do I find y? Plug it into an equation. I'm going to plug it way back into this equation right here. So 18 plus 2y equals 12. So 2y equals negative 6. So y equals negative 3. So it's the ordered pair 6, negative 3. How do I check my answer?
Graph it.
No, which I could, but it's hard to graph these on a graphing calculator because y is not a low. Plug in the numbers. 24 plus 9 is 33. 18 minus 6 is 12. If you plug the numbers in for x and y, you can make a really quick check. Okay. Now sometimes you'll get no solution. Okay, if I want to create opposites out of this, I'll multiply by the top row by 2. 6x plus 4y equals 10. Negative 6x minus 4y equals 10. If we add to my columns, I get 0 equals 20. Does 0 equal 20? No. So it's no solution. If you would graph these lines, they'd probably look like that. If you have parallel lines, then there's no solution because parallel lines never intersect. They never cross. Where they cross is the solution. So if they never cross, there's not a solution. On this one, I'm going to multiply my top row by negative 3. So I get negative 9x minus 18y equals 30. My bottom row is 9x plus 18y equals negative 30. If I add, I get 0 equals 0. So if 0 equals 0, then I have infinitely many solutions. And you go, well, what's infinitely many solutions? Well, you have to find two numbers that work for this. Just off the top of my head, well, I'm going to solve for y. And then I'll find my numbers. So I get 18y minus 30 minus 9x, or 18y equals negative 30 minus 9x. If I divide by 18, y equals, divide by 6, negative 5/3 minus 1/2 x. And I want to find a number that works in there. So, I don't like those numbers. So a number, 5/3. Yeah. There's going to be lots of ugly numbers for this one, but yeah. Never mind. I don't think on the assignment there it gets overly complicated. We'll see in a second. PreCalc. Where'd you go, PreCalc? Down right there. 718. Okay. So on your first problems, you just stick 3 in for x, 7 in for y, and figure out if there's a solution to both equations or not. Okay? That's easy. For this one, it says use a substitution method, so you get x equals 26 plus 4y. Stick the 26 plus 4y in for that x and solve and find x and y, like we did before. It says substitution here. I don't care which method you use. I would myself use elimination on this one. I'd multiply this row by -3 and this top row by a +2 and do elimination. This one, I'd get x alone on the top equation and plug that in for the x of this equation and solve it. Okay, substitution for this one. Y equals x squared, y minus 36 equals 0. Take the x squared, plug it in for y. So x squared minus 36 equals 0. X squared equals 36. If we take the square root of each side, x equals positive or -6. So if x equals positive or -6, the solutions are 6, 36, and -6. Well, what's -6 squared? It's also 36. Okay, so those are the two solutions. Elimination, just add your columns. Here, I'd multiply by 7 on the top row, 5 on the bottom row, add your columns and solve. And then, yeah. So if there's infinite solutions, you just circle it in. You don't have to find any solutions. Okay? So I will put that out there so that way you have time to work before lunch. After lunch, we'll look at some graphing with some of this stuff. Okay? So there we go.